You're going to need some friends. Here we go. 34. And a lunch, because it'll be a long day. We want to prove, you guys pay attention. I know it's almost time to go, pay attention. We want to prove that even functions are kind of a double reflection. So we're going to say reflected over the x-axis and then the y-axis.
Mr. Adams, it's kind of blurry.
I know, it'll autofocus in a second as soon as I stop writing. Okay, so what we want to do is we start with the function y equals f of x. Okay, and remember that the definition of an odd function is that when y equals f of x, right, if I take f of negative x, it's equal to the negative of f of x. Okay? That's what an odd function is. And so I'm going to leave that up there on the screen. Now, what we're saying is that if a function is odd, oh, I wrote down even. That'll make it difficult. The other problem was even. This one's odd. So we're going to prove that an odd function is nothing more than a reflection over the x-axis and then a reflection over the y-axis. So I wrote down the definition of what an odd function is, and by definition, we learned a section or two ago, that when I plug in the negative x value, I should get the negative y value. That's the fancy formal way of saying that. And we also kind of said that we say that it's reflected over the origin, and then Mr. Adams said, well, it's actually reflected over the x-axis and then reflected over the y-axis. And so they want us to prove that. And there's lots of ways you could do it. You could start by doing it graphically. You could start, there isn't any one set way to do it. So what I'm going to do is I'm going to start with this definition. All right? So if I want to make this look like this. So if I start with y equals f of x and I reflect it over the y-axis. If I reflect over the y-axis, according to our textbook, the reflection over the y-axis then becomes y equals f of negative x, because that was the definition of reflecting it over the x-axis. So now the next thing I would do would be what? Reflect over the x-axis. So now if I reflect over the x-axis, how did we reflect over the x-axis? Well, to reflect over the x-axis, I would just, if I started with f of x to reflect over the x-axis, I would get negative f of x. So if I were to do both those, what do I end up with? I end up with y could equal this, or y could equal that. Well, if they both equal y, aren't I saying that this is equal to this? Does that make sense? Now, that's not a real formal proof. The formal proof says let f be an odd function, that is, f of negative x is equal to negative f of x for all x in the domain of f. To reflect the graph y equals f of x across the y-axis, then we need to make the transformation of y equals f of negative x. But f of negative x is equal to negative f of x if it's an odd function. that is the translation or transformation that reflects it across the x-axis. So in other words, for f of x to be an odd function, you would have to first flip it this way, then flip it this way. Does that make sense? So that is exactly the translation that reflects the graph across the f-axis of x-axis, the graph of f across the x-axis, so the two reflections yield the same graph. Does that make sense? In other words, what they're saying is, if it is an odd function, then this should be equal to this. Well, if I take the graph and reflect it over the y, I get this. And if I take it and reflect it over the x, I get this. And if it is an odd function, then these two should equal one another. Well, what does that mean? If they equal one another, then that means that I've reflected over the y and I've reflected over the x. I didn't write all the words down, but we're kind of ramping up to get you guys ready to start thinking logically and doing proofs. Do you guys have any questions on that?